Welcome back. Today we are going to discuss on Bayes theorem, and the contents are Bayes theorem applications, and we are going to solve few examples on that. Yes, coming to Bayes theorem, why we use this Bayes theorem and what is a Bayes theorem? So Bayes theorem generally describes a probability of an event based on the prior knowledge. So already we know about that, so we are going to discuss. And Bayes theorem is particularly useful in situation where we have a knowledge about probability of events and want to revise those probability as for new evidences. So it has many applications. They may ask you mention some of the applications of Bayes theorem. It has many applications in the field of medical diagnosis, medicine learning, statistics, decision making processes. So that you can write it for 5 marks. But Bayes theorem is very important. Definitely it will going to appear in the question paper for 5 to 8 marks. So for that you have to write a definition, and then we have a formula for Bayes theorem, probability of occurrence of an event. So that event A occurs on B is defined as probability of B by A into probability of A divided by probability of B. So what is A? B is a probability of A occurring given B is true. So A occurs when B is true. So B by A is probability of B is occurring given A is true. So B occurs when A is true. So PA, the probability of A here, it is nothing but probability of an event A. P of B is probability of event B. So after writing this, we have steps that are there in the theorem. So what is the step 1 is define the probabilities. So whenever the problem is given, first you define the probabilities. So what are the probabilities? Maybe the probability of A, B, probability of B over A. So whatever that comes in the formula, define those probabilities. That is the first thing. So after defining the probability, what is the second one? Substitute values in the Bayes formula. So this is the Bayes formula. After determining the probabilities of A, B, P of B by A, substitute those values in the formula. Now after substituting, calculate probability of AB. So calculate this. So then you will get the result. So this is how the steps you need to remember, and by remembering the steps you have to solve the problems. So once we solve the problem, you will get clear what you have to do it. So the problems will be like this. Suppose in a medical test, if a patient has certain diseases, so probability of disease is 0.01%. So probability of testing positive is 0.09%. Probability of no disease, that means probability which is contradictory to probability of A. So that contradictory is, I'll write it as 0.05%. If the question is like this, then what you have to do is test the following. You have to test and find out what is the probability of A over B, that is AB. So now after getting this problem, we have to test what is the probability of that particular diseases. There certain disease has been tested positive or not. So what is the first one? Define the probabilities. So what are the probabilities? Just define. So what is probability of A? Same thing. Yes. So I have defined there. So instead of that, if you put it here, that becomes step 1. Then what is the second step? Calculate the probability of B. So what is the probability of B? Probability of B that I have to calculate equals same Bayes formula. Probability of B by A into probability of A plus probability of B A. It is complement of A. So why we are taking complement? Into probability of A that does not occur. So here we are taking complement because in the question we can observe that B is tested positive with no disease, Tested positive is there, tested positive with no disease. So B, if I want to calculate, there are two things. One is tested positive and one is after testing positive, 0.05% rate are fake. I mean those who have declared as positive, out of that 5% are not tested positive. So that is the meaning. So that is why we are calculating this probability. So now substitute this, I'll just try to substitute the values here. So probability of B is that is probability of B over A 0.99, okay, into probability of A. So what is probability of A? That is 0.01 plus probability of B over A, that is 0.05, tested positive but fake, into 0.99, the probability of not occurring of A. So if you substitute, so you will get 0.0594. This is the second one. Then substitute in the base formula. So same formula, that is 0.099. So what is the base formula? So same formula, I have to write it here. Just write the base formula. So probability of A, occurrence of A by B is equal to probability of B of A into probability of A divided by probability of B. So this is the base formula. Here I have to substitute those values. What is 0.09 is probability of B over A, okay, into probability of A. So into 0.01 divided by, so what we got, that is a fake 0.0594. So after simplifications, whatever we get it here, after simplification, so 0.090 divided by 0.0594. So what is the answer? So this will be 0.1667. So this is the answer. So calculated. After calculating, write this here 0.1667. So that is nearly, which is equal to 16.67%. So 16.67% we can accept that positive rates of the disease or whatever it is. So this is how you have to solve the problems if such kind of problems are given here. So tested positive, based on that you have to solve. So I have taken another example here. Imagine we have a deck of 52 playing cards. We want to find the probability that a card drawn is ace given that it's already known heart. So event A is 4 by 52. So what is A here? Is ace. Ace are 4 out of 52 and we have 13 hearts, that is 13 by 52. Heart is ace. One ace is also heart is also, that is combination is 1 by 4. So I am writing the base formula here. So after writing the base formula, substitute. So what is P of A? That is 1 by 4 into what is A? 4 by 52 divided by probability of B, that is 13 by 52. Substitute. After substituting, simplify this. After simplifying, you will get 7.69%. So like this, step by step we have to analyze whatever it is given. So this is step 1. So here what we have done is step 1, define the probabilities. Step 2, write the base formula. Then substitute the values into the base formula. After substituting, simplify and find probability of AB, that is probability of B. So if you do this, when in case in the exam in the question paper, if they ask us to find using Bayes theorem, you can do it. If they didn't ask to solve us using Bayes theorem, you can solve it generally by probability. But if they mention it as a Bayes theorem, then you have to do it. So generally they will be asking what is a Bayes theorem example. Then you can explain it and take any one example out of that. So that's about the Bayes theorem, the definition, and given taken simple examples so that it will be very easy to solve it and understand. So thank you for watching. Please do like, share, and subscribe. Thank you.